Hello everyone, we are APM Construction. My name is Alejandro Rivera.
I'm Pruthviraj Thakor.
I'm Melkin Frutuoso.
And today we will be discussing the beam analysis and design for PCI Big Beam competition. So a little bit of our presentation today. We will start with the project background about PCI Big Beam competition. We will talk about our specific approach. Then we will dig into our specific design and our final product. And with that, we will top it off with a cost estimate for the final product. So a little bit of the project background. PCI Big Beam competition pretty much tells us to design a pre-stressed concrete beam for a 20-foot long span. It has to hold 2-point loads of 16 kips at their respective location, as you can see in this image. And their judging criteria is based on design accuracy, lowest cost, lowest weight, and also largest deflection at max load. So based on that judging criteria, one of the requirements for PCI is to meet 32 kips at the midspan for a point load at midspan of 32 kips, and also not to surpass 39 kips with a point load at the midspan. So with that said, we decided to design for a range of those two limits with 2-point loads of 18 kips at their respective locations. We also decided to pursue an I-beam. And also pre-tensioning was our method of pre-stressed. Since this beam was going to be manufactured by Finfrog, they only do constant eccentricity, and based on information from their plant, their concrete is most of the time, their compressive strength for 28 days is 10 KSI, and their initial compressive strength is 4.5 KSI. So based on the requirements and our approach, now we will talk about our specific beam design. So in this slide, you guys see an image of our final product, just to get a base of what we designed. Our cross section, as you can see, has a height of 12 inches, 12.5 inches. The bottom flange has a 13-inch width, and the top flange is 9 inches of width. Now we'll be discussing the steps that we took in order to get this final design. I will leave it with Melkin, which will start it off with the pre-stress estimation losses.
Hi everyone. Based on our approach and preliminary calculation, our pre-stressed beam design is composed of 3 half diameter stressless strand and constant eccentricity of 3.22 inch. This table shows pre-stress losses that occur at each stage. As you can see, the percent total losses was 24.4%. Alejandro again.
Hello. So based on our cross section and also the 3 strands that we decided to incorporate based on the pre-stress losses, here's a summary of the beam stresses at the midspan and also at the support section. As you can see from this table, all of the limits passed based on our cross section and the 3 strands. The only one that didn't pass was the bottom flange. It had a tension more than the limit. So that just means not to worry. That just means that the strands are not going to cover all the stresses that are being produced at the bottom flange. So with that said, we had to design for a partially pre-stressed beam. And this is what I talk about here in this slide. So we calculated the cracking moment, which was almost 650 pounds per inch. And the overload moment, as you can see, was more than that. So that just means that there was going to be cracking at the bottom flange, as you guys saw from the previous table. So based on that, we had to design for a non-pre-stressed reinforcement, which included 2 number 3 bars at the top flange and 3 number 3 bars at the bottom flange. And these profile, they met the minimum and maximum requirement based on our cross section and also the steel requirements. As you can see from this profile and this reinforcement, We got a nominal moment, which was more than the ultimate moment, that just means that our design was good. So based on that nominal moment and our specific reinforcement, our deflection, our max load before our beam fails completely is going to be 38.5 kips at the midspan, and that will develop a deflection of 0.71 inches.
Hello everyone. So this slide shows us the shear and anchorage reinforcement design. This sketch basically shows us the half cross section of the total span of the beam. So here you can see that there's a 41 inch of area which requires no shear reinforcement. That means there are no stirrups which we required over there. Then coming over here, there are web shear stirrups which we calculated from the design methods, and the result was number 3 U bars spaced at 9 inches center to center. For 72 inches, we will have 9 stirrups for this. And then here you can see that we have anchorage stirrups which have number 3 closed ties. This is since the half of the cross section, it's going to be exactly same on the other side. So moving on, here you can again see the final product which we designed. You can see that there are 2 number 3 bars on the top flange. There are 3 number 3 bars in the bottom flange. Over that you can see the pre-stressed strands, and this is the U stirrup which we use for the web. So based on this design, we calculated the total cost of the beam, which is going to be $203.71. This table basically shows all the material which we used, and the cost is distributed accordingly. There is one interesting thing which you can see is forming takes up the major cost, and this unit cost is given by the PCI Big Beam Contest. So with that said, this is all for the presentation. Thank you for your attention.